Welcome to Get Your FRQ On. This question is from the 2004 exam. It's question 1, and it is calculator active. In the question stem, we're giving a formula for f of t, which gives the rate of traffic flow through an intersection at any given time t, and the value of t is good for however long it's good for. That's given in the question stem. Part A, we're just asked how many cars go through the intersection in the first 30 minutes. Well, since f of t represents the rate at which cars pass through the intersection, the actual number of cars that pass through the intersection can be found by using the definite integral from 0 to 30 of f of t dt. Now, that's just a basic fundamental theorem of calculus question. If you have a rate and you want to do total accumulation, you just integrate your rate function. All right, but this is a calculator active question, so we're just going to use our calculator to integrate our f of t function. The integral from 0 to 30 of f of t dt is the integral from 0 to 30 of 82 plus 4 times the sine of t over 2 dt. And if we use our calculator to calculate that definite integral, we get about 2,474 cars. In part B, we are asked if the traffic flow is increasing or decreasing at time t equals 7, and to provide a justification. Well, the traffic flow will be increasing or decreasing at t equals 7 depending on the value of f prime of 7. So if f prime, or if f represents the rate at which traffic is flowing, is that traffic flow increasing or decreasing? Well, we need to know f prime at 7. So this is a calculator active question, so we're going to use our calculator to calculate the derivative of f at 7. So f prime of 7 is just the derivative of our traffic flow function evaluated at x equals 7, which on a calculator we get about negative 1.873. And again, because it's calculator, you can round this to either 3 decimal places or you can truncate to 3 decimal places. Either one is acceptable. However, since f prime of 7 is less than 0, we can conclude that traffic flow is decreasing at time t equals 7. In part C of this question, we are asked to find the average value of f of t over the interval from 10 to 15 minutes and provide the units. Well, the average value of f of t over that interval can be found again using an integral. We just use the formula for average value of a function. Right, so that'd be 1/5, because 15 minus 10 is 5, times the integral from 10 to 15 of our f of t function, which is 82 plus 4 times the sine of t over 2 dt. Again, calculator question. Let the calculator do the hard work. So using our calculator to calculate what 1/5 of that integral is, we get 81.899 cars per minute. In part D, we are asked to find the average rate of change of traffic flow for the interval of time between 10 and 15 minutes and to provide units. Now, because f of t is, it involves at worst a trigonometric function, that trigonometric function is sine. Sine doesn't have any discontinuities. We can conclude that our function f of t is in fact continuous on that interval. We could also conclude that it's differentiable. But that's not necessary to use the average rate of change formula. But it does have to be continuous, so you should state that. And then we can just use the formula for average rate of change of a function, provided it's continuous, which is why we need that first step. All right, so we use the formula for average rate of change. That would be f of 15 minus f of 10 over 15 minus 10, which is f of 15 minus f of 10 over 5. But again, it's a calculator active question, so we're probably going to need our calculator to evaluate f of 15 and f of 10. And if we do that, we get 1.518 cars per minute per minute. Right, remember, we are asked to provide the unit here, so make sure that your unit is a rate of our original function f. But since f is itself a rate, our unit is going to be a rate of a rate, and so that's how we get cars per minute per minute.